Hi to all those budding matriculants out there. What we are going to do for you is a DVD, or a few DVDs in fact, on revision of paper 1 and paper 2 in mathematics. What happens with your paper is it starts with the easy questions. Now, questions are rated as level 1 up to level 4. Level 1 is called knowledge, and that means I just know how to do it because I go and find the formula in the formula sheet, I substitute into the formula, and I know exactly what I'm doing. Level 2 is called routine procedure. You don't really want to know these words, but at any rate it means I've got a little procedure to do before I get to the answer. Now, level 1 and level 2 questions, basically 50 to 60% of the paper will be those sort of questions, and they will be organized in any order, but they will be, we can almost say, easy questions. So every one of you out there should be aiming for at least 60% for mathematics, because you all can get 60% for mathematics. After that, we get level 3 type questions. Now that's called complex procedure. Now I would say the next almost 30% of your paper are level 3 type questions. Now those are questions you've done. You've done them in class, maybe word sums, maybe maximums and minimums in calculus, maybe finding equations of tangents that are just slightly different. In other words, questions that are on the syllabus. And then level 4 questions, problem solving. Now those questions are questions that basically aren't on the syllabus. Now 10% of the paper should be problem solving. So we are going to concentrate very much on level 1 and level 2 questions. Now, just to tell you a little bit about these DVDs, we are going to do it in sections because it is easier to do it that way. But at the end of each sort of section, we are going to give you, in your workbook, you will see the same examples that we have done on the DVD. And then after that, you will have a little exercise with about 6 or 7 up to 10 questions that you have got to do. Because what do I say to you? Always, maths is a doing subject. It means you've got to get stuck in and you've got to actually do the work. It's absolutely no good just seeing what I do. Oh, now I know how to do the question. Watch what I do, then go and try yourself. Right, let's start with the first section. First section I'm looking at is simplification of algebraic expressions. Right. That means there might be a little bit of exponents, there will be that grade 11 algebra, and there will be a little bit of logs. And as we go through, so we will talk also a little bit about the theory. Let's look at question 1. Now, this could happily be the first question in your maths exam. Simplify. Now, what do I do with this question? What do you have to do? You can cancel, but you may only cancel factors. So the first thing you've got to do is actually factorize that expression. So let's go. So I've got x and x, which gives me x squared. This is easy because your second factor has got to be 2 and 1. So it's not negotiable here. So it's got to be x, and it's got to be 2 and 1. A total level 1 type question. Right, I now look at my signs, and I've got to have a negative times a positive. Right, but my bigger one has got to be negative. Right, I now take the factor in the denominator, and yeah, easy one, common factor, x and x minus 2. And yes, I can now cancel the factors. There's no ways you can cancel the x's. We end up with x plus 1 over x. Let's check how many marks. I would imagine 1, 2, 3 marks. 3 marks, level 1 question. Could be first question on the exam. Let's look at the next one. Again, it is going to say simplify. Okay, the question is simplify. Now just be careful. I've had so many bad experiences with these easy simplify questions. Nobody's asking you to find x. They're simply asking you to write this as one term. Now, how would you do that? It's like a half plus a third. What do? You simply find the common denominator. Now let's put this over 1. Right. my LCD. I take out the 1. I don't need to put it there. But there's my factor, the entire factor, x minus 1. Now, just like you did in grade 6, 1 into x minus 1 goes x minus 1 times, but I must multiply it by x. Plus x minus 1, when I divide into there, cancels, and I get x. And now it says simplify, so I've got to go ahead and simplify the numerator, and I get x squared minus x plus x over x minus 1. And we end up with simplifying again the numerator, x squared over x minus 1. Again, level 1 type questions, simplification. Let's keep going with the simplification, and just one, maybe level 2 type question, routine procedure. Right, now let's go. What must I do? I want to get the lowest common denominator. So look, I've got x minus 2 and I've got 2 minus x. So guess what I'm going to do? I'm going to multiply the top and the bottom by negative 1. And if I do that, I'm keeping the sum exactly the same, but I'm making x minus 2 the same as x minus 2 in order to get the lowest common denominator. So let's go. I'm rewriting the sum. X plus 3 over x minus 2. Now, I'm going to put a minus there. So I've got minus 1. And if I put a minus there, because what you've got to do to the numerator, you have to do to the denominator, I'm going to get what? X, see, plus x minus 2. Yay! Yay! I've now got the lowest common denominator, which of course is x minus 2. X minus 2. X minus 2 goes into x minus 2 once, and I get x plus 3. Minus 1, which gives me x plus 3 minus 1 is plus 2 over x minus 2. And remember, there is nothing you can do with that, because this is x plus 2 and that is x minus 2. There's nothing you can possibly cancel. Now, just before I go on to the next concept, just things to look out for that you might see when you actually do your 10 sums. Be careful. If this had said 1 plus x, put it in a brackets because of this negative sign, because the negative sign plays tricks with you. Because you've got to remember that if you've got a negative times a negative, it becomes a positive. Or a negative times a positive is a negative. So you would need to change the signs. So just watch and just remember, it's going to say simplify. And simplify means all I've got to do is write it as one term. All right. I would say in the exam, there'd probably be about 5 or 6 marks on that particular section. Now, they're also going to ask you to simplify where exponents are involved. So let's just go through the rules. The rules that you learned when? Basically in grade 8. Okay. Rule 1. If I've got x to the a multiplied by x to the b, I have a rule. Bases are the same. We are multiplying at the exponents. So that's x to the a plus b. If I've got x to the a divided by, so I'm going to do it like this because that's what we do in grade 12 and grade 11. I say base is the same, I get x to the a minus b. If I've got x to the a to the power of b, we say we are raising a power to a power. I get x to the a over b. Now, before we actually go on to the next one, exponents are so important. Not because they are going to be asked in their own capacity, but basically because they come into calculus, they come into logs, they come into sequences. So let's just talk a little bit about what you know about exponents. Right, firstly, If I've got 2 to the minus 1, what does that mean? It's basically 1 over 2. Why? Because if I had 2 squared over 2 cubed, by using that rule we showed you, rule number 2, I would have 2 to the 2 minus 3, which is minus 1, which you can see if I had cancelled would be 1 over 2. So 3 to the minus 2 is clearly 1 over 3 squared, 1 over 9. A, B to the minus 2. Now be careful. That is A to the 1 times B to the negative 2, which means I've got A times 1 over B squared, which gives me A over B squared. And then the other one is the magic one of exponents, which tells me that anything to the power of 0 is 1. Why? Because if I've got A to the 6 over A to the 6, clearly I can cancel that and I get an answer of 1. But if I use that rule, that second rule, what have I got? A to the 6 minus 6, which is A to the 0, which is 1. Once again, be careful. If I've got 3 times 2 to the 0, that is 3 to the 1, which gives me 3 multiplied by 1, which is 3. Okay, let's play with exponents. Question. Again, could be in the first section of your maths paper. Simplify. We are still on to simplify, involving exponents and using those rules. Right, simplify. Let's go. Most important thing about exponents, and you're going to find in logs as well, is we've got to write it as a prime factor. So if you see a 6, it's not 6, it's 2 times 3. If you see a 4, it's 2 times 2, which of course is 2 squared. And incidentally, very good idea to learn your powers of 2 and your powers of 3. But at any rate, let's carry on. And what have I got here? 3 I'm happy with. 3 to the x multiplied by. Now, what is 10? Prime factors. So I'm going to write it as 5 to the 1 times 2 to the 1 to the x minus 2. Now this 1 and that 1 is clearly not needed there, but I'm putting it there to remind you you've got to use that power rule. Okay, so now let's carry on. 2 I'm happy with. 2 to the x. 15 must become 5 times 3. Again, prime factors to the power of x. Right. Third rule, raising a power to a power. 3 to the x. Now, careful. 5 to the x minus 2 multiplied by 2 to the x minus 2 over, I'm happy with 2 to the x, and here I've got 5 to the x multiplied by 3 to the x. See, once again, remember each one. So if you want to, put those ones in. They're not necessary, but it just avoids careless mistakes. Right, now, rule number 1, rule number 2. If you're multiplying, you add, provided the bases are the same. And if you are dividing, you subtract. So I'm going to put down the 3. And look, x, anything on the bottom line, I say, in the denominator, I change the sign. 5, x minus 2 minus x. And 2, x minus 2 minus x. Which gives me 3 to the 0 times 5, x minus x to the negative 2 times 2 to the negative 2. Now, we're looking at everything I said to you a little earlier on. 3 to the 0, 1, multiplied by 5 to the negative 2. 1 over 5 squared. 2 to the negative 2, 1 over 2 squared, which gives me 1. 25 times 4 is 100. Right, happy. So that is exponents. That's the sort of question you might get in exponents using the rules. However, there's more to exponents than meets the eye. Remember, in exponents, if there's a plus or a minus sign, it's like a robot that says stop. There's no rules. There's no rules for plus or minus. Just like in an algebraic expression, there's no rules for plus or minus. You can't add unlike terms. Right, so if you've got a question like this, plus minus sign, robot. Remember what happened in the first question we did today? What did we have to do? We had to factorize to cancel those factors. We do the same. So what do I do here? I'm going to split it up. I cannot use a rule. I cannot say 3 to the x, add 1. Why? Because that would be multiply, and it's not. It says plus. So I've got to split up with the aim of getting out that common factor. So I go 3 to the x plus 3 to the x times 3 to the 1. And let's see that you understand that. 3 to the x times 3 to the 1 is exactly the same as 3 to the x plus 1. Right, underneath. Again, I've got 3 to the x minus 3 to the x times 3 squared. And now we are ready. Why did we do that? Because we want to get out that common factor so we can cancel the factors. Out comes 3 to the x. Now again, be careful. 3 to the x is out of there. There's not nothing there. It's 3 to the x multiplied by 1 plus. Took out the common factor of 3 to the x. I've got 3. Double check that you're happy with that. Underneath, take out a common factor of 3 to the x. What's left? 1 minus 3 to the x is out. I've got 3 squared, which is 9. I can now cancel the factors that are the same. And I mean, a little bit of arithmetic there. 3 and 1 is 4. Over 1 minus 9 is minus 8, which gives me minus a half. Right, we're still on simplification. Logs, exponents. That was exponents. I'm now going to look at logs. All right, let's quickly once again go through rules of logs. I've got log any base to the a plus log same base to the b. Now logs are exponents, so it's the same rule. If I look at it like this to give you a little bit of theory, I've got 3 squared equals 9. That's an exponential equation. I can rewrite that and say 2 is a log. It's a log. Now, log is a piece of wood, so I've got to explain exactly what happened. It's a log to the base 3 of 9. That is the same expression written as a log. Let's do one more. Let's say I say 2, see 2 again, is the log of 4 to the base 2. Now 2 is still a log, but it's different exponential expression. What am I saying here? Base is 2. Log is 2 equals 4. So in other words, logs have the same laws as exponents. What happened when you added the exponents? Yeah, you were multiplying the numbers. So I got log base m a times b. Right, same story. Log a, any base you like, p, minus log b. What did we do when we subtracted exponents? What were we actually doing? Yeah, we were dividing the numbers. So I've got log base P A over B. And finally, I call it the jump up, jump down law. Gives me log A to the power of M is the same as M log A to the P. Why? It's the same rule as the exponents. I'm raising a power to a power. What do? I multiply the exponents. What are exponents? They are logs. Let's just use this rule a little bit. Remember I told you about the magic one of exponents? Well, of course, we've got a magic one of logs as well. So let's see where the magic one of logs comes from. 3 to the 1 is 3. 5 to the 1 is 5. You all agree with me on that? A to the 1 is A, general case. Log form, 1 is log of 3, base is 3. Exponent, log. 1 is log of 5 to the base 5. So, hey, guess what? We've got our 1 of logs. 1 is the log of A to the base A. Now, I needed to show you that because to really understand logs, you have to understand that. But understand one thing, that logs are not a huge, huge part of the actual examination. So you will get a couple, maybe 5 or 6 marks involving logs. But where logs become very important is in log application, which comes into financial maths, which Mark is going to be doing with you. So I'm not going to do one of those, I'm just going to do a couple of questions involving logs. All right, simplify as a single log. So, I'm using the log laws. First law is that jump up law. Right, now let's use this one of logs and see how we're going to use the one of logs. So let's say I've got log 8 to the base 2. Now, again, just like exponents, logs have got to be written in the simplest possible form. So I've got log base 2. And what's 8? 2 times 2 times 2, which is 2 cubed. Now, I can hop down. I call it the hop down into the fire and the hop out of the fire law. Right, just now we will see how we use the hop out of the fire law. Here I'm hopping in. And what law is it? It's the third exponential law, which is raising a power to a power. So I jump down and I get 3 log 2 base 2. Who is this? The magic one of logs. Answer is 3. Right, let's do an example using, a couple of examples using the laws. Simplify as a single log. Now, first law, I can only use my addition law of logs if I have log A and log B. So my first thing is to use the reverse of the law I've just shown you. And what do I get? Log A squared. Exactly the same as 2 log A plus log B cubed. Now they said a single log. So what am I doing? I'm adding the logs together. So what do? I multiply the numbers. A squared, B cubed. Now we are going to give you some examples in the activity where you are using numbers. But I don't think they're going to give you that in the exam because you can just cheat on your calculator. You've got a calculator, you can just plug it into your calculator and get the answer. Right, now let's look at this. This they could easily ask you. And I've been asking my students questions like this because you can't use a calculator. If log 2 is A and log 3 is B, find in terms of A and B log 12. Now, the rule tells me that when I'm multiplying the numbers, I add the logs. So this has got to be written as multiplication. So I'm going to write this as, in its prime factors, log, break it up. I've got 2 times 6, which is 2, times another 2. 2 times 2 is 4, times 3. Now, there we go. I'm multiplying the numbers, so I add the logs. So I've got log 2 plus log 2 plus log 3. Level 2 question, which gives me an a and another a, 2a plus b. Now, if we look at this question here, I've got log 2 and I've got log 3. But remember the magic one of logs. I've also got log 10. Log 10, base 10. Log 10 is 1. Now, we come to this question here. Sorry about this. Let me write this nicely here. I've also got the fact that log 10 is 1. Now, I want to find log 5. Sorry. I want to find log 5. It's got to be multiplication and division. I cannot say, I cannot, not, let's go, not log 3 plus 2. There's no rule that tells me what to do with 3 plus 2. Not. Now 5 has got to be written with these numbers here. 10, 2, and 3. Any of these numbers such that you've got either division, which means I'm subtracting, or multiplication. So take a minute to think. Of course, 10 divided by 2. So I'm going, this is the same as the log of 10 divided by 2. Rule! Great rule! Dividing the numbers, subtract the logs. What have I got? Log 10 minus log 2. Log 10 is the magic one of logs, minus log 2. And what was log 2? Let's go back and look. Log 2 is A. Done. Now, that is all I'm going to cover in actual simplification. But as I said to you, after watching this, my suggestion, pause the DVD and go. You will see these same examples written down for you with a little worksheet of about 10 examples with the solutions at the back of the book for you to actually go and try. What did we say maths is? Of course, yes. Maths is a doing subject.